equation, and this method can always be used to find the particular integral whenever the complementary function of equation 1 is known. Okay, so this is important. So you should be able to find this complementary function. Okay, if you can find complementary function, then you can use this method of variation of parameter. Now you see this is the complementary function. So here variation of parameter means this constants a and b will vary. Okay. So the idea is to vary the parameters a and b. So we will consider a and b as the functions ax, bx. Okay, this we have done last class. Okay. So if you put ax, bx, this is what this solution is. Okay, complementary function. Now the general solution of this one. Yx contains two functions ax and bx which are to be determined. Okay, so we need two equations to determine them. The ax, bx, the equation is obtained by substituting yx from 3 in the equation 1. Okay, so one equation is obtained by substituting yx from 3 in the equation 1. Now differentiating equation 3, this one, we are getting this. Okay, and here we can consider we can set this one 0, or this is the condition. Okay, we are putting on y1 y2 that this will be 0. Now y dash equals to this much. Again, if you differentiate, so y double dash x will be this one, a y1 dash this. Now you substitute the expressions for yx, y dash x, and y double dash x in the equation 1. Okay, the non-homogeneous linear equation. Okay, of second order. So after substitution, this is what we are getting, and we are able to, after doing the simplification, the coefficient of a is this and b is this. Now you remember y1x and y2x are the solutions of this non-homogeneous linear equation. Okay, so this will be equals to 0, and this also equals to 0 because y1x and y2x are the solutions of homogeneous equations. Okay, here, this one. So corresponding homogeneous equation means this equals to 0. Okay. So here we have. So once you set this to 0, we are left with this much. Okay. And you can set this one equals to gx, rx by a naught. Okay. And this a naught is not equals to 0. Okay. So gx is continuous in the given interval. Now this these two conditions. Okay. This is one condition. We set this one. Okay, so this is and this is. So these are the two equations from these two. If you solve, we are getting this. Now, if you look at the denominator, it is nothing but the Wronskian. And here Wronskian is not 0. So that means y1 and y2 are linearly independent solutions of homogeneous equations. They are solutions, but once the Wronskian is non-zero, we will be getting the linearly independent solutions. Okay. Now the equation 4, this one, you can write in the denominator the Wronskian of x. Okay. And here, this for the sake of calculation, since we know this is this much. So now a dash, b dash. So you have to remember this ax, bx. Okay. So this is what you should remember. Ax is the solution when this happens, where ax is the coefficient of y1. X and bx is the coefficient of y2. Okay, so this is g of x into y2 by w of x. Wx stands for the Wronskian. Okay. Similarly, this is gx into y1, w of x is the Wronskian. Okay, we will integrate this. See, now I will tell you how to use this equation. Okay, that is, it's easier if you do a problem. Okay, let's see.
What is the value of gx? Means what is gx? Can you repeat, please?
Gx, here we are getting this gx. Gx is r of x by a naught.
Okay, thank you.
R of x is what? It is the what you have in the right hand side of the non-homogeneous linear equation. You see the first one. This is r of x. Okay. And this is a naught x, the coefficient of y double dash. Am I clear? Now you have the gx from the equation. Yes. Rx by a naught. And we are making sure that this a naught is non-zero. Okay. See here. So we will find the general solution of this equation using a method of variation of parameter. of variation of parameter. Okay. So now we will look at the solution. So for the solution, right hand side to 0, because this one is a non-homogeneous linear equation. So this is the corresponding homogeneous equation is y double dash plus 3y dash plus 2y equals to 0. So now you find the characteristic equation or the auxiliary equation. Okay, both you can say that the characteristic equation or auxiliary equation. So it will be m square plus 3m plus 2 equals to 0. Now what are the roots of this equation? Minus 2 and minus 1. You can look at it. These are the equations. Okay. So now the complementary function yc. So it will be a y1x plus b y2x, and you can write y1x will be e power minus x mx, then m2x dv into exponential minus 2x. Okay. So this is our complementary function. Now these two constants a and b, we will consider them as the, we will vary them. So they will be the functions of x. So here y1x equals to e power minus x, and y2 x is exponential minus 2x. Okay. So this we have, this is a complementary function. Okay. So here they are the linearly independent solutions. Linearly independent solutions of this one, you can say. One. Now we assume the general solution as general solution as y of x equals to a of x into e power minus x plus b of x into e power minus 2x. Okay, this is the general solution. And we will find ax and bx. Okay. Our purpose in the method of variation, this is what from the complementary function we are getting, and now I will find ax and bx. So gx, you know, gx is r of x by a naught. So you find out what is r of x. This is 2 e power x and a naught is 1. So 2 e power x and a naught is 1. Okay, so 2 e power x. This is your gx. Okay. So now the next thing is we will find the Wronskian of y1x and y2x. So here w of x goes to y1, y2, and here y1 dash, y2 dash. Okay. So if you put it here, the y1x and y2x here, we have e of minus x and minus 2x. And if you do the derivative, it is minus e power minus e power minus 2x. So if you go minus e power minus 3x,
minus 2 e power minus 2.
it's minus 2. So here we will write out minus 2. Sorry, this is only, I think, minus. Because it will be e power minus 2, e power minus 3x. So minus minus plus e power 3. So it is minus e power minus 3x. Okay, this one is right, the Wronskian. So this is the Wronskian. Okay. Next. So Ax, we know what is Ax. So Ax is minus g of x y2x divided by Wronskian dx plus the constant. So gx is 2 e power x. Then we have y2x. y2x is e power minus 2x. And this, so after simplification, it will be e power 2x plus c1. Okay. So 2 will be here, and you see it will be e power minus x and minus minus plus. So if you take this one up, so it will be e power 3x and minus x will be e power 2x. And 2 is here, so integration will give you 2 gets cancelled. So this is our what our a of x. Okay, similarly, you can find for the b of x. So b of x is, it's not minus sign, it's not there. So g of x, y1x divided by round scan of then dx plus c2. Gx 2 e power x then e power minus x, and we divide it by minus e power minus 3x. Okay, so you see, so it e power x, e power minus x got cancelled, and if you take minus up and e power minus 3 plus 3x, so it will be 2 minus 2 by 3. Okay, so this is v of x. So now we have the solution. We have y1x, y2x, ax, bx. So the general solution. So the general solution. So if you substitute, this will be ax e power minus x is the y1x, dx is e power minus 2x. Okay. So here, if you want, you can further simplify. So here you can see e power 2x, here e power minus x, e power plus x, and c1 e power minus x. Then here minus 2x, so it is minus 2 by 3 e power x. So here also e power x is there. E power x, and here minus 2 by 3 e power x. So we will have plus 1 by 3 e power x, and the second one is c2. So this is our y of x, the general solution. You can also find in the normal process. This is one of the method to find the general solution. You see, this first part represents the complementary function, what we have got. And this is actually we are getting here. So one more you can find. So we find the general solution. Okay, do it by using this variation of parameter. Okay, find out. Done, anyone? Done, anyone? here. Done, anyone? So here, what will be the complementary function? So the complementary function, so here we have m square plus 1 equals to 0. So m is plus and minus side. So here, y, the complementary function will be a, and here we have cos x plus b sin x. If the real part is 0, so here the particular integral here, if you consider, it will be x cos x plus bx sin x. Okay. Now we have y1, y2. Okay, we will find the Wronskian. Okay, so that so here what is y1? So if you look at here, y1 equals to cos x, y2 equals to sin x. So here the y1, y2, y1 dash, y2 dash. So here cos x, sin x, and here sin x minus sin x, and this is cos x. Okay, so this is 1.
Yes,
Cos
ma'am.
square x plus sin square x. So 1. Okay. So now it's easy here. If you go for a of x. What is g of x? We'll find out g of x. So if you look at here, g of x is cosec x by 1. So it is cosec x, g of x. And here 1 is the coefficient, so it will be the cosec x. So g of x minus sin x here. y2 x divided by the Wronskian. So this is cosec x, y2 is sin x. So this is 1 in the numerator, and in the denominator we have 1. So it is minus x plus c1.
Yes, ma'am. Minus x.
And dx will be g of x, y1 x, dx plus c2. So it is cosec x, cos x, y1 dx. So how much is this integral?
Log of sin x.
Log of sin x.
Sin x. Yes, ma'am.
Log of sin x plus c2. Okay, so we have ax bx. Now the general solution, c1 minus x, and here we have cos x plus log sin x c2 sin x. So is there any scope of further simplification? So sin x log x, sin x log of sin x, and then we have x cos x. C1 cos x, the complementary function part. Let's write C2 sin x. The first part, the complementary function. So here what we have written for the a cos x, b sin x. And the next we have
Minus
minus
x
x cos x plus sin x into log of sin x. Okay, so this is your particular integer. So one more you can do. One more we will do. Give it for 6. So find the general solution. So it is 16y 32 sec 2x. Okay. Using method of variation of parameters. Like the previous one, we are built with the geometric function. Find out. Okay, so here if you look at the characteristic equation for the complementary function, so since the auxiliary equation is m square plus 16 equals to 0, mx plus and minus 4i. So here it is a cos 4x plus b sin 4x. Okay, so the general solution. So by method of variation, it will be x cos 4x plus bx sin 4x. Okay. So here, this is y1x and this is y2. Okay. So next is we will find the gx. Gx is rx by a naught. So we look at here, rx is 32 sec 2x. And here for a naught is 1. Next we will find the Wronskian of y1, y2. So here, so it is cos 4x, sin 4x. So what will be here? Minus, anyone done? 4 sin 4x.
4.
Is it right?
Yes, ma'am.
Then this will be 4 cos 4x. And what will be here?
4.
4.
4
Yes, ma'am.
cos square 4x plus sin square 4x. So this is coming as 4. Okay. So ax so gx is 32 sec 2x. y2x is sin 4x. Sin 4x. And we divide it by 4. Okay. So dx plus the constant. So how much you are getting?
8 cos 2x plus 7.
8 cos 2x. Okay. Or you can write it as minus 16 sin 2x dx. Plus c1 and we are getting 8 cos 2x. Okay, so this is your x. So in the same way you can get it px by using the formula. So it will be 32 sec 2x into cos 4x. So divide it by 4 dx plus c2. So just tell me the answer. What will be here? What is the answer here? 8 sin 2x minus 4 log sec 2x plus tan 2x. Are you getting this much?
Yes, ma'am.
Yes, ma'am.
Plus c2. So now you can substitute here the general solution. Y equals to ax y1x plus bx y2x. 8 cos 2x plus c1 and y1x is cos 4x. Then the long one, ax sin 4x. Plus c2 sin 4x. C1 cos 4x, so the complementary function part, plus C2 sine 4x. So this is the complementary function part. Then we have 8 cos 2x into cos 4x. And here 8 sine 2x into sine 4x. So finally, I'm writing the answer. Okay, 4 sine 4x and multiplied by the ln sec 2x plus tan 2x. Okay. So check your calculation. If I'm missing anything, you can also say. Okay. So this is the, yeah. Yes. What are you saying? Done or any doubt? So last one you calculate. Okay. So now we will consider the general equation. General linear equations with constant coefficients. Okay. Is there any doubt with the previous method? Okay. So general.
Ma'am, we can use this method in any equation, right?
Yes, any. Like the previous cases, what we did, the particular integral with those sine and cosine formulas, there also you can use.
Okay, ma'am. Thank you.
So here we have general linear equations, general linear differential equations with constant coefficients. Okay. Now, what is the form for this one? So, if you consider the equation xn, then dn. Dn means the nth order derivative. Okay. Plus p1 xn minus 1 dn minus 1 plus p2 xn minus 2 dn minus 2 order. And in the nth, we will have 0, and here it will be pn. D n minus 1 plus the last term will be pn. This we multiply it by y equals to f of x. Write it again. So I'm repeating the equation so that I can make it in one line. So it's the linear equation. So here we have f of x. Okay, general linear differential equations with the constant coefficient. Okay. Consider the equation. So we will consider this equation of nth order derivative is there. Okay. Then here P1, P2, Pn are all constants and fx is a function of x. So here P1, P2, Pn are constants and f of x is function of x. Okay. So the above equation you can be reduced to a linear equation with constant coefficients by substitution. Okay. So this equations you can reduce it to a linear equation by doing a substitution. So let's see what will be the substitution. Okay, so here, so what we do here, we will substitute x is equal to so similarly you can try for d cube also. So d cube y But we are restricting ourselves to the second order, so I didn't try it. Okay, you can try for D cube also. Okay, so let's put one form. Okay, once you have reduced this one, then we have the normal procedure. Okay, we will substitute this one in the original equation, and the equation will reduce to the linear differential equation with constant coefficients. Okay, and we will solve it by the methods like we are solving for the linear differential equation. So let me solve one. Okay, so if you want, you can write it in this form: x squared b squared minus xd minus 3y equals to x squared log x. And you can do these substitutions. See, x dy will be d dashed y, and x squared d squared we can write it as d dash squared minus d dash. So minus xd, so x dy will be d dash minus 3y. So here we have x squared log x. So t is log x, okay, and x is e power t. Okay, for the solution, okay, what we are putting, x equals to e power t, then t equals to log x. Okay, so this is what we are putting. So here you can put x square e power 2t, and this log x is t. Okay, so this is now this reduces to y and t form. Okay, so you can open this one. So we have d dash square minus 2d dash minus 3 y equals to t into. So we will solve this equation. Okay, this is our equation which we are going to solve. Okay, so the auxiliary equation will be m square minus 2m minus 3 equals to 0. So the solutions, what are the solutions for m? 3 and minus 1. Okay, so the complementary equation will be a power 3x plus b e power minus 6. Okay, so now, so here, sorry, this is for t variable. We are solving it for t. Okay, so we have 3t and minus t. Okay, next you can solve it for any form. Okay, particular integral, normal form, or the method of variation also you can put it. So yp, the particular integral, will be 1 by d dash square minus 2d dash minus 3, and here we have t into e power 2t. So we can use the formula e power ax bx form. Okay, so if you take 2 e power 2t to this side, we will replace d dash by d dash plus 2. Okay. So if you simplify here, so plus 2d dash plus 4 minus 2d dash minus 4. So this gets cancelled out. We have minus 3 left. So Okay. So here, what we will take common? Minus 3 we will take common. Then we will have the, okay, minus 3. So here, okay. So now we can go for anything I missed?